Glinda is a new user experience for data science. With Glinda, data scientists can read, clean, transform, and visualize data, as well as build, test, and deploy machine learning models. Glinda is an extension to Visual Studio Code that divides the work into two panes. The left-hand pane allows the user to express the steps of their workflow in a domain-specific language. The right-hand pane allows the user to work with data through interactive visualizations. These two panes work together. Each step is intended to combine the expressiveness of a written notation with the ease of use of a GUI. Glinda uses live programming to keep these two mutually consistent and up-to-date. Let's see a demo. A few steps from the Glinda tutorial. First, we'll load a dataset about passengers aboard the Titanic. Because Glinda uses live programming, as soon as I've entered my first step in YAML syntax, it's immediately evaluated, and a table appears on the right. The table is interactive and allows me to sort and filter the values. Now let's create a decision tree model to predict who survived. Since women and children were given priority on the lifeboats, let's use age and gender as our features. After my YAML syntax is complete, I see an accuracy curve. With live programming, I can comment out individual features to see what effect they have. We are currently building the model on the entire dataset, so let's add an intermediate step to take a sample of the data. The output of each step is the input to the following step. Adding an asterisk after a key in the YAML creates a UI element for editing that key's value, in this case, a slider. I can use the slider to see what effect the sample size has on our model's accuracy. As a last step, let's create a new feature to extract a passenger's title from the name column. I'll add another step which uses the Microsoft Prose library to do programming by example. The UI for this step allows me to add examples in place. Adding my first example modifies the YAML, which in turn causes the learning algorithm to rerun, which then updates the UI. At first glance, the titles look good, but to be sure, let's add a plot to look at the distribution of the title column. The histogram shows quite a few blank titles. So let's sort the table to bring the blanks to the top and add a second example. After the titles have been relearned, the histograms show there are very few remaining blanks. The title column now seems good enough to add as a feature to our model. As a second example, here I'm using Glinda as part of a data app. This Glinda file builds a deep net to recognize hand-drawn images. On the right, we can see a sample of the images used for training and two plots that show the model's loss and accuracy curves. At the end of each training epoch, these curves are updated, acting as a dashboard. That is, the interactive visualizations update both in response to my edits and in response to the ongoing computation. Once training is complete, the model is saved locally where I can use it in my app. We ran a qualitative evaluation in which 12 professional data scientists compared their experiences in computational notebooks and Glinda. Overall, they felt that liveness and the high-level language made them feel productive. They also had many useful suggestions for ways in which to improve the tool. For details, please see our paper.